Hey everyone, this video is a review of the stoichiometry and chemical reactions practice test. First question, why do chemical reactions need to be balanced? They need to be balanced because as chemists we are not all-powerful beings, but instead simply people who can arrange atoms. When you do chemistry, you are just making and breaking chemical bonds. You are not creating matter out of nowhere. So the number of atoms on each side of the equation need to be equal. If you started out with 12 carbon atoms and 2 oxygen atoms in your reactants, you must have the same number of atoms of each type in the products. Atoms are not created or destroyed. There are types of chemistry, such as nuclear reactions, where new elements can be made, but we haven't talked about that yet, and generally those aren't considered normal chemical reactions. A balanced chemical reaction does not tell you about the actual amounts of materials present. What does it tell you? Well, it tells you the ratio of moles of reactants and products. The balanced chemical reaction does not tell you anything about what you actually have in front of you in terms of amounts. For example, a reaction in which you performed, you made water when we did our mole rockets. And this balanced chemical reaction looks like this. The 2 in front of the hydrogen and the implied 1 in front of the oxygen, those are not the amounts you actually have in front of you per se, but instead it's the ratio in which they react. 2 moles of hydrogen molecules react with 1 mole of oxygen molecules to produce 2 moles of water molecules. You could also read this on an individual atom or molecule basis. 2 molecules of hydrogen react with 1 molecule of water to produce 2 molecules of, 1 molecule of oxygen to produce 2 molecules of water. Moles in molecules are the way you can read the chemical reaction. You cannot read it with grams. This is not true. 2 grams of hydrogen do not necessarily react with 1 gram of oxygen gas. You can read it in terms of molecules or moles. When we balance the following reactions and determine their reaction type, we get different types or classes of reactions. The first reaction balances with 1s in front of all of these substances. In essence, for the purpose of this activity, I've put 1s, but when you actually look at chemical reactions in general, if there's nothing written in front, of course, we've talked about this, how it's implied to be a 1. This is a single displacement reaction because, as you'll notice, the barium and the calcium are changing places. The barium comes in and displaces the calcium in the products. Potassium chlorate decomposes to produce potassium chloride and oxygen. This is an example of an accelerant that could be used to speed up or make more intense a combustion reaction. If you add potassium chlorate, what you're doing is you're adding extra oxygen to the environment when it decomposes, feeding the fire. Decomposition, because this one substance is falling apart. The numbers in front, the coefficients, do not dictate the type of chemical reaction. Even though there's 2 potassium chlorates, it is still considered a decomposition because it is only 1 substance on the left of the arrow. Magnesium and oxygen come together to produce magnesium oxide. This is called a synthesis reaction, also sometimes called a combination reaction. You'll hear people refer to both of those. Again, it's irrelevant what the coefficients are. What matters are 2 separate substances coming together to give you 1. Potassium chloride and lithium fluoride do a double displacement reaction where each of them switches partners. Notice that the positive metals, potassium and lithium, switch places. You never get a positive-positive combination because those repel, and you never get a negative-negative combination between the chloride and the fluoride. This is considered an acid-base reaction, iron hydroxide or iron 3 hydroxide, reacting with nitric acid. This is acid bases are, in this form, are a form of double displacement, really, because what you get is the OH and the H combining to make water. This is why acids and bases neutralize one another. It's because with most classes, there are different ways to describe acids and bases, but the one we're going to study in this class is most acids start with the element hydrogen, and bases have OH, hydroxide. Metal hydroxide is what makes a base. So when you see an OH and an H, they can come together to make water, H2O, neutralizing the acidic part of the acid and the basic part of the base. Water and a salt are produced. A salt is something made of positive and negative ions. Another word for a salt is an ionic compound. C3H8 and oxygen. When you see carbon-hydrogen, that's called a hydrocarbon. If you go on to take AP Chemistry, you'll find that these are organic compounds, and we name this propane. Now I know you're familiar with this substance because it is used in your gas grills. And when you have a combustion reaction, whether or not it's made of carbon and hydrogen, or it could also be carbon, hydrogen, and oxygen, and I've used A, B, and C as variables, and you combine it with more oxygen, you get carbon dioxide and water as your products in a combustion reaction. Notice that whether it's carbon or hydrogen, or carbon, hydrogen, oxygen, when they combine with oxygen and burn, you get the same products, carbon dioxide and water. How many atoms are there in a mole of magnesium atoms? You have 6.022 times 10 to the 23rd atoms in a mole. You have 6.022 times 10 to the 23rd anything in a mole of those things. This is known as Avogadro's number, and it is the number of particles in a mole of those things. How many molecules are there in a mole of NH3, also known as ammonia? There are 6.022 times 10 to the 23rd molecules. If you're talking about one mole, you're talking about that many things. What is the molar mass? Molar mass is the mass in grams of 1 mole of a substance. It's determined by the atomic masses from the periodic table. If we're talking about just the element oxygen, the number underneath oxygen is 16.00. 16.00 grams per mole. On the bottom is 1 mole, grams per 1 mole. If we're talking about water, we have to add up all of the individual atomic masses. Because there are 2 hydrogens, we use twice the atomic mass of hydrogen, and then we add that to once the atomic mass of oxygen. 16 plus 2.02 leads to 18.02 grams per mole for the substance water. This is the end of the video for page 1. I realized that I did not move the paper up, so I wanted to show the work for the last problem that I just described with molar mass. I had talked about the oxygen and the molar mass of water. Individual atoms, 16.00 grams per mole is the molar mass of oxygen, sometimes also known as the atomic weight. And the molar mass of water, you have to add up the individual atoms, giving us 18.02 for water. This is the real end of the video for page 1.